And how to measure the efficiency of power amplifier? You will see corrector efficiency eta is given by PL by P sub. PL is going to be the average power delivered to the load, and P SUPP is the average power drawn from the supply voltage. So the collector efficiency or the drain efficiency, in MOSFET you call it as drain efficiency, in BJT you call it as collector efficiency. So it is going to be load power by supply power. And we also have one more efficiency called power added efficiency. It is given by PL minus Pin by supply voltage. Pin is the average input power, and PL and P sub, it is going to be the supply and the. So this power added efficiency will have an major say on the linearity of an amplifier. So when the amplifier is going to work at high powers, linearity becomes the question. So what happens because of non-linearity? So when non-linearity happens, the adjacent channels will start interfering and amplitude start compression. So you know that when you draw the graph of an amplifier, as you increase the input power, output power will increase. The output power will increase as it reaches saturation. The output power starts reducing. So that is what is shown in amplitude compression. So after a particular saturated input power, the output power starts reducing. So the power amplifier functionality is gone. And because of non-linearity, you will have all those harmonics coming, which will lead to interference.